Hello out there. I hope you're doing well on this beautiful day. What is our focus today? Today what we'd like to focus on is a regression. Okay. What does regression entails? Do you know? Do you have any idea what it entails? Okay. But before we do that, I'd like us to start with a question. And I'd like you to think about this while you're at home there. Let's see what we have. So my question is, have you ever thought about this? How do we predict the future based on data collected over a period of time? How do you really predict the future based on the data collected over time? Can we really predict? How much data do we need to predict? Can I have 5 data sets and predict what will happen? Okay? Another way we can predict that is using this regression analysis. Okay? So regression analysis, which is a model with independent and dependent variable, the x and y. Okay? And we can use that to predict the future. You could have seen also with the COVID-19, okay, that data have been collected on a daily basis, how many people infected with the coronavirus. And data was used whether to have a lockdown or something, and data was used to predict whether we're going to have a second wave or third wave, something of that nature. Yes, using historical data, one can predict the future, okay? But to do that accurately, one will need a large data. I mean, using 5 data sets or 10 or 20 might not really be that efficient or optimal, but using a large data, you can accurately predict what will happen in the future. Okay, fantastic, great. So now, what are we going to focus on? We'll look at the line of best fit. After the line of best fit, we'll look at linear regression from there, and we'll look at something called interpolation and extrapolation. Okay, that's when we're actually trying to predict using data. Okay, so let's look at some of the keywords: forecasting and statistical model. What is forecasting? Okay. Surely, if you weather, also the weatherman will focus the weather. Say, okay, there's this chance that it might rain tomorrow. That's another way of forecasting, predicting whether it will rain tomorrow or it will be hot or cold or something of that nature. That's actually forecasting. If we have data and we want to predict the future using the data we collected, we're also forecasting. Are we all together? Then, what are we using to forecast? We're using a statistical model to forecast that. And a linear regression is one of the statistical model that can be used to forecast. Forecast meaning to predict what is happening in the future. Are we all together? So if we have collected the coronavirus data, we want to see whether and we predict, yes, we're going to have more infection by next week. We're actually forecasting using the data collected. That's what we're doing, okay? But to forecast, there are different models. When we talk about a model, it's model to focus the data. But we'll focus on one model today, looking at linear regression on how can we forecast. Okay. So without wasting time, what is independent variable and dependent variable, okay? So on a Cartesian plane, my x is independent variable and y is the dependent variable. I mean, independent variable does not depend on other variables, but dependent variable, it will depend on the x variable, it will depend on something else. Are we all together? Independent and dependent variable. Then from there, let's look at the line of best fit. Okay, you've probably heard of the line of best fit. What is the line of best fit? So when a relationship exists between, very important, between 2 variables. So the 2 variables we're talking about here is the independent and dependent. Could be x and y, okay? So when relationship exists between two variables, a line of best fit can be drawn on a scatter plot or scatter graph. What is a scatter graph, guys? If I have x and y as coordinates, I put a points on the Cartesian plane in the first quadrant, I put all those points. We call that a scatter graph or scatter plot. Are we together? Okay. So the simplest relationship is a linear relationship. So we're going to look at linear relationship only when you draw a scatter plot. Okay, fantastic. So the line of best fit, we draw our points on a scatter plot and we find a line which actually all those lines closer to that, all our points get closer to that line. Okay, but we'll explain that in more detail. So a line of best fit. For a linear relationship, the line of best fit always passes through the point x bar, y bar. What is x bar, y bar? So those are the mean, is the average. Okay, so remember that x bar is given by sigma x over n, and y bar also is given by sigma y over n. What does that mean? This implies what we're doing is the sum is the average of x and this is the average of y. Remember that the average of x, we take all independent variable, all the x's, we add all of them, we divide it by how many of them. Okay? We do the same on the y-axis. We add all the y values, divide by how many y values do we have. Are we together? Then that's the average for y. So what we're saying is that the line of best fit must pass through the mean. So you have to create a new point on the Cartesian plane by calculating the average using x, the average using y, create a new point, and the line of best fit must pass through that mean, the point, which is the new point you must create. Fantastic. Are we together? Makes sense? Okay. Let's see what does that look like. So here we have points. So we say the line of best fit can be added to the scatter graph, okay? Showing the mean, January temperature, and altitude. So here we have temperature and we have altitude. So the points were drawn. Those are the points there. Are we together? For us. So to draw the line of best fit, we create the new mean. Are we together? Which is that point. How do we get that point? So that point is x bar, y bar. The x bar, this point is by the average by, say, 10 plus 20 plus 30 plus 40 plus 60 divided by 1, 2, 3, 4, 5. Are we together? And you do the same thing on the y-axis. You add all the temperature and divide it by how many data set. Then that will give us that point. Then we draw our line of best fit. Are we together? Are we together? So it might not be exactly the same line of best fit, but what must be the same, it must pass through the same mean. The same mean is that point. The average for x and the average for y. The line must pass through that. Very, very important. Are we all together? Okay. Fantastic. Great. Now, I would like us to look at a linear regression. What is a linear regression? What is this linear regression? Okay. So, a linear regression is actually the line that represents the line of best fit. It's actually the best one. Are we all together? It will be the equation of the line of best fit. That will be the linear regression. Okay, in a simplest term. So linear regression involves finding the equation of the line of best fit on the scatter plot. It's find the equation of the line of best fit on the scatter plot. That's what we're doing. That's our linear regression. Okay, let's see. So the equation obtained then can be used to make an estimate of one variable given the other variable, of the other variables, okay? So there are two cases to consider, depending upon whether we wish to find the value of y given the value of x, or we want to estimate x given y. Okay. We deal firstly with a situation where both variable x and y are random. Okay, I'll illustrate that. And where we wish to predict the value of y given x. Are we all together? So if I find, we said that linear regression is the equation of the line of best fit. In this context, we're talking about the equation of a straight line. And if we have that straight line, we can find y using x. If we have x, we can find y. Okay. So let's look at this. I'll show you. So the best fitting line is the one that minimizes the sum of square deviation. Okay. So this is the line of best fit, if you can look at that. But remember now, I have all those points. Those are the points there. Those are the points there. Those are the points there. Those are the points. Those are the points there. So we want to choose the equation of a straight line that minimizes the deviation from the line of best fit. Can you see? We want to reduce that distance. Okay. Okay, are we together? So those are the sum of the deviation from the points of the scatter plot. Are we all together? So if that sum, the deviation from the line of best fit is so large, we don't have a good model. We don't have the good or the best line of best fit. Are we together? So we want to minimize this. This is what it's actually trying to say. Are we together? So sigma, this just means the sum of those deviation, all of them, all of them, all of them. We want that to be minimum as possible. Are we all together? Okay, that's the line of best fit. So this does not mean that the regression is only linear. It could be a different model. It could be parabolic, it could be exponential, it could be any function we can think about. Okay, so the idea is to minimize this. So now this is our line of best fit. So the distance, di, are sometimes referred as residuals. You know, worry about that. So those deviations. So it implies that those d1, d2, d3, d4, d5, those are the residual. So di is the vertical distance between the ith point and the line. That's what we're trying to do. Are we all together? Great. So, regression. The best fitting line should pass through the mean, which is the average, which is x bar, y bar. Okay? The equation of the least square regression, okay, of y is given by this. Y, actually there must be a copy there. Y equals to a plus b times x. This looks more like the equation of the straight line. Are we all together? So you know that the equation of a straight line, you're probably used to y equals to mx plus c, which is similar, where m is the gradient and c is the, so this is the slope, and this is the y cut, or y intercept. Okay, so it's the same. So even here, so this is the slope of the regression line, and this is the estimate. So both the estimate for y cut and estimate for the slope of a line. Are we all together? And we spoke about it must pass through the mean which is average for x and average for y. Okay, guys, so we're going to take a short break now. After the short break, We'll still look at how do we actually find this equation of the least square regression. How do we find that? Using our calculator and actually using the equation of a line, okay? I hope you're doing well out there, and remember to keep working hard, keep the consistency going there, okay? You don't do your mathematics because you're writing a test. It's a continuous thing that you do on daily basis, and you become continuous on that, okay? Great, fantastic. Hope to see you shortly. Hello out there, welcome back once again. We're still working on regression, okay? And I hope you've understand something at this moment, okay? And remember, we'll iterate that again. To be successful in your mathematics is continuous hard work. And it's okay sometimes not to understand something, but what is important is what you don't do. What do you do when you don't understand, okay? Is that consistency, okay? So we don't wait for an assessment, for a test to come, for exam. Then we're starting to seek for help. We seek help same time during our challenging times. And if on a continuous basis, you work, you will see your challenges will decrease with time, okay? Welcome back, hope you're ready. Remember to have your pen and paper, and that's how we do maths. You know, we don't observe or you read a textbook. Yeah? You need something to write, to try some of the problem, and to think also. Okay, fantastic. Welcome back. So now what are we going to look at? We're going to look at linear regression. So we have defined what is a linear regression. So we said linear regression is the equation of the line of best fit. Are we together? And what is important that the line of best fit must pass through the mean. Are we together? Pass through as a point. Passing through the mean implies we have to calculate the average for x, the average for y, and create a new point which we include on our scatter plot. And the regression line must pass through there. Now, the focus of this part is how do we find the equation of the regression? When we talk about regression, I'm talking about the equation of a straight line, but which is the best fit. How do we really find that? Okay. So let's see. So here, there's a regression question. So using a calculator, determine the least square line. So the least square line also is the same thing, just the least square line, we're talking about the regression. We're talking about the line of best fit, okay? It's exactly the same. So the least square line of the best fit for the following data. So here we have learner, okay? So we have learner 1, so we have a learner. So there's the learner 1. So they wrote the test. So the first learner for chemistry, marks was 52%. Accounting marks, 48%. Learner 2, chemistry mark was 55%. And accounting, 64. Chemistry, 86. Accounting, 95. And we have 71 for chemistry there, 79 for accounting. Lastly, 45 chemistry, and 50 for accounting. What do you see from the data? Can you draw any conclusion? Does it mean a high mark in chemistry, you'll be better in accounting? But we have a sample of 5 students, okay? But let's try and draw some conclusion based on that. What do you think out there? So if you look at this, 86 and 95, we can see that a higher accounting mark based on student 3 is a high, based on high chemistry, a high accounting mark. And also we can see that the lowest, not really the lowest, if you look at student 1 and student, does it mean a lower chemistry means a lower accounting. Could be. It could be. But to see this, the best way is actually, let's try and find the regression. We model this. We have an equation that represents that. If we have an equation that represents that, we can see what is happening. Are we together? Okay, let's see. So, for a chemistry mark of 65, let's assume, okay, so we have chemistry, we have the lowest is 45 and the highest 86, okay? So let's say for a chemistry mark of 65, what mark does the least square line predict for accounting? Okay, so the least square line, we're talking about the line of best fit, okay, or the equation of the line of best fit. Are we together? Now, we don't have, on our data there, we don't have 65. But let's say student gets 65 for accounting. Can we predict he gets actually 65 for chemistry? What will be the marks for accounting? Will be higher? Based on the data, indicates higher. But what is the mark for accounting? So the only way we can do that, if we can find the least square line, the equation of our model. And let's see how we do that, okay? Using our calculator. So using our calculator, getting to your calculator ready. So I would like you to get your calculator ready, okay? Switch on the calculator, okay? I'll indicate using my calculator. What I'd like you to do first is to press mode, okay? On your calculator. After mode, select STAT, which means stats. How do you select it? So it's mode, after mode, STA, by pressing 2. After doing that, guys, the following should appear. You should see something like this on your calculator. If you don't see something like this on your calculator, something wrong. You see something like that? Are we all together? After that, you press 2, press 2, press 2 is that. Can you see? That's 2. That's like the least square line, the straight line. Can you see that? Where A, B is the slope, A is the estimate, y-intercept. You select 2. After you select 2, you should get something like that. What does this mean? We have to put our X, our chemistry mark here, and we have to put the accounting marks there, because we're given chemistry marks and accounting. So we have to put chemistry there and accounting there. So it's the independent data and the dependent data, the X data and the Y data. Are we all together? That's what you must do. Okay. So to do that, so for example, entering the data, you're going to say 52, which we had for what? For chemistry. So 52, then equal to enter the first mark. Then enter other values in the similar way, in the same way. For X variable, the chemistry mark in order in which they were given. That's very important. The order must be exactly the same. You can't change that. Then move to the cursor, okay, across, up, and enter 48 under Y, opposite 52 in the X column. Good. Then this is what you must see. So you have entered your X and you have entered your Y value. That's where we are. Are we together? Are we together? So let's see that using our calculator. So using our calculator, I have to enter my chemistry mark. So this is mode. Can you see that? Select 2. Then I select 2 for the regression there. I can see A plus B times X. There I'm getting my X and Y. Then let's enter that. 52 equal. Then I move this the other side. What is my Y? 48 equal. Then I move this side. 55. Are we together? Equal. Then move that side. What do we get? We get 64 equal. Then we have 86 equal. After 86, we had 95 equal. I think we had 4 data set. Let's see what we need. We had 4 data set, so we need another one. So we actually had 5. Okay, let's see. See, we have everything correct. So we have 55. So the first one is 52, 48, check, 55, 64, 86, 95. The fourth one we have 71. Agreed? Equal. After 71, we have 79. Equal. The fifth one, lastly, which is 45. Equal. Then I move my cursor that side. I get 50 equal. That's my data. Are we together? That's where we are. We've entered our data now. That's where you must. After entering our data, this is what you must see. Now, you're going to press AC, okay, the screen, to clear the data. But the data remains stored. It will be in the calculator, okay? Then you press Shift 1 to get to the stats computation. After Shift 1, you must see something like that. So now we're going to say AC, Shift 1 to get to this position. Okay. After that, we choose regression by selecting 5. If you choose regression by selecting 5, we should get this. Can you see this? This is our A and B. That's what we want. Are we all together? We want the value of A and the value of B. And also remember that R means correlation also. Okay. Then from there, we press 1 equal to get the variable for the y-intercept and the gradient to 2 decimal places. Okay, let's see. So we have our data there. So I'm going to say clear, AC, Shift 1. What did we say? We said 7 for regression, not var. 7, I select 7. That's what I get. So what do I want? I want the A value. I select 1A. Are we together? Equal. Then my A value, which I can see it's 5 point. I can see there's the A value. Let's go back. There's my A value there. Okay. Then for the B value, I'll do exactly the same way. So I'll go back. I can say AC, Shift 1, 7. Then I want the B value 2 equal. Then I get my B value. See that B value correct? So my B value is 1.16. Okay. Okay, so to get the slope, we agreed to use the following key, Shift 1, 5, 2 equal. So the calculator gave us the B value, which is that, to 2 decimal places. Are we together? Then our equation of the regression is that. Are we together? Which is our equation of a straight line, our y-intercept, and our gradient, which was given to us. Are we together? Okay. So what did we do there? We just had to put our data. Putting our data. We say AC, still store the data. Shift 1. Are we together? Then you select regression. After selecting regression, you should get the value of A and B, the slope and the gradient of the regression line. Then that's how we write the equation of a straight line. Okay. So what does it mean? So now we can predict, so this is the accounting and this is the chemistry, which is the independent variable. So it implies if we have the accounting mark, the chemistry marks, we can predict what is there. If we have the chemistry, we can predict the accounting marks by substituting, by replacing X with the chemistry marks. Are we all together? That's what we can do. And if you remember, we're given that the chemistry marks, what about the chemistry mark of 65%? If we go back. Let's go back. So now how do we predict if you get 65%? What is my accounting mark? Okay, let's look at that. So to do that, if I go back, where's my regression? Okay, there's my regression. So while I see X, I just have to put 65. Are we together? So let me see that. I can do that, clear that. So I can see my calculator minus 5.07 plus 1.17 bracket, we have 65. We want to see equal. Oh, I'm getting actually 70 point, if I round to 70.98. So it's 65% chemistry leads to, if I round to one decimal place, is 71%. Okay. So guys, so in the next segment, what we'd like to talk about also, is this prediction really good? Is that reliable? Can I use it? And when? Can I trust this? That, oh, if I get 65% for chemistry, for accounting, I'll get 71% for accounting. Okay. We hope to see you guys after the break looking at, is this reliable? And how reliable is this? Okay. See you shortly, okay? Just drink water or something and come back strong. See you in the next, shortly. Cheers. Welcome back once again, guys. Okay, so we've looked at our regression model, what it looks like, okay, and we looked at using a calculator doing that. And we said it's an equation of the line of best fit. And we use our calculator to find the y-intercept and the gradient for the least square regression or the line of best fit. Okay, that's what we did. But now, what we're going to look at now is something called extrapolation and interpolation. How do we use the line of best fit to predict, okay? And do we really believe on the reliability of that? Can I say, yes, this is a good prediction. I'm confident about this. And what do we use to argue that, okay? So we'll look at interpolation and extrapolation. So inter, you can see, is in, within a data, and extra, it's outside. We're extrapolating outside the data. But let's look at what does that look like, okay? So we had Elena, okay? So we had Lena, 1 to 5. We had the chemistry marks there, all the chemistry, and we have the accounting marks, okay? And we use the data to find the least square line or the line of regression, which we did using our calculator, okay? Now the question is, for a chemistry mark of 30%, what mark does the least square line predict for accounting? Now, you get 30% for chemistry. What is the accounting mark? If you look at the data. Then the next question is, for a chemistry mark of 65%. Okay? What does the least square line predict for accounting? If I get 30%, what is my accounting mark? If I get 65% for chemistry, what is my accounting mark? Okay, that's what we want to look at. But before we look at that, let's explore what is interpolation and extrapolation. Okay. So, interpolation. A regression equation can only confidently be used to predict y that correspond to x value that are within the range of data value that is interpolation. Are we together? Okay, so if we predict within the given data, given data, we are interpolating. Okay, and that is what is important. With confidence, we can predict y. If the data we have is within the range. Okay. Let's look at interpolation, okay, using the line of best fit. What does it look like? So we have our dependent variables there, our independent there, okay, we can see that. We have our points, and the blue is our least square line or the line of best fit. So from there, that position, all the way to there, there was the data given to us. Are we together? That triangle. So if we predict, let's say I want to know, if my x is 6, I want to know what is y. I'm interpolating because 6 is within the range. What if I use 11? Yes, 11 I'm also interpolating because 11 is within the range of the data given. Why interpolation? What does that mean? Okay. It's reasonably safe to make prediction within the range of the data. So if we interpolate, the reliability of the prediction is really good. Okay? Are we all together if we interpolation? But there, outside, the range of the data is something else, which we'll talk about it, which is actually known as the extrapolation. So let's look at the extrapolation. It can be dangerous, okay, or not accurate. The forecast, the prediction, to extrapolate. To predict, that's what you're talking about, or forecast, from the graph, the value of y that corresponds to the value of x that lies beyond the range of the values in the data set. This is because, why? This is because we cannot be sure that the relationship between the two variables will continue to be true. Okay? If my range is from 5 to 15, I want to know what is happening at 20. Will the trend be the same? Will the same pattern be the same? We don't know. So we can't really rely on that prediction. Okay? But if it's within the range, we can really rely on that because we are interpolating. Are we all together? Okay. Let's look at interpolating. How does it look like graphically? Extrapolating. This is extrapolating. So the range for this is from there to there. This is a given range. That's the range. Now, beyond this 15, at that point, we are extrapolating. If I want to know what is happening at 16, at 17, at 18, I'm extrapolating. And it's really dangerous, especially on the reliability of our prediction or the forecast. Okay, we cannot really rely on that because we don't know what is happening beyond the range because we need more data. If we can collect more data and update our regression line, maybe we can. But if we do forecast or predict using extrapolating, we just have to say, is our answer is not reliable because we are extrapolating. Okay, we're good. So let's go back to our chemistry question. Okay. So remember we're given 1 to 5 linear, we're given the chemistry marks and the accounting marks. So given chemistry and accounting, now we calculate our regression if you remember previously. I'll update that again. So now the question is, so let's look at the range for this. The range, the minimum value is 45. The maximum is 86. If I predict any number between 45 to 86, I'm interpolating. But after 86, I'm extrapolating because the range is 45 to 86. Okay. Now, for a chemistry mark of 30%, what mark does the least square line predict about accounting? If I get 30% for chemistry, what is my accounting mark? What is my accounting mark? And is that reliable? Is 30% interpolating or extrapolating? Is 30 within a range? I don't think so, because the minimum is 45 and the maximum is what? 86. I'll be extrapolating, I think. Okay. Now, for a chemistry mark of 65, what mark does the least square line predict for accounting? Okay. Let's look at that. So we do know that this is our least square line. We calculated previously is the equation of the line of best fit for chemistry, accounting, and where X is chemistry and Y is the accounting. So to predict this, what we need to do is where we see X, we substitute 30 minus 5.07 plus 1.17, 30. And what is this? I'm going to use my calculator. Okay, so I put this on my calculator, so it's minus 5 minus 5.0, not point, delete, 07 plus 1.17. Remember, this is the line we calculated using our calculator. And we're given now that chemistry is 30. What is my accounting? That's what I get, about 30. Let's go back. It's about 30.03. Okay, percent. So if you get 30 for chemistry, the prediction, the forecast is about 30% for accounting. Is this reliable? No, not reliable at all, because we are extrapolating. We are extrapolating because of the given data, the minimum is 45, the maximum is 86. We're predicting outside the range, not a reliable prediction because of big extrapolating. Okay, are we together? Because we don't know students performing around 30% for chemistry. We don't have the data to predict that. So it's okay with predicting 30, but not really accurate. We're not confident about that. Okay. But what about the 65? The 65%. Okay, similarly, let's see that. So 65%, let's predict and see what we get. So we just have to substitute. Let me just update, minus 5.07 plus 1.1, delete, 1.117, bracket, where I see X, I have to put what? 65, because 65 is what? Is my chemistry, and Y is my accounting. I want to know what I'll get for accounting. Which is what? Okay, which is, Let's see what we get. We get 70. We get 70.718 or 9. Let's see that again. 798. Now, this is percent. So if you get 60 for chemistry, you will get about 70% for accounting. Okay? What do we say about this prediction? If you look at 65%, it's within the range. We are interpolating. I'll use the word. We are interpolating because we're interpolating that prediction. Confident about that prediction. That yes, if you do get 65% for chemistry, there's a good chance of you getting about 70% for accounting because we are interpolating. But the 30% we had, we are extrapolating. We don't trust that prediction. Okay, guys, fantastic. Hope this makes sense. So what we looked at, guys, our summary, we looked at the line of best fit, we looked at regression, we looked at interpolating and extrapolating. So the line of best fit is, we draw it from the scatter plot, but remember it must pass through the mean. And the linear regression, I used my calculator to calculate the A value and the B value. And be careful when you forecast or predict, use interpolation and extrapolation. I hope you enjoyed, guys, on this beautiful day. And we hope to see you soon. And I will encourage you to keep working hard. And good luck.